Today's lesson is about inscribed and central angles. So I've got about 6 problems that we're going to go ahead and practice inscribed versus central. So let's first talk about what inscribed angles are. And let's see, I'm going to just kind of draw right here on the center. I'm really bad at drawing circles, so I think I'm just going to trace this hand lotion to get a nice clean circle. So let's see. I'm going to trace 2. I'm really bad at drawing circles. So let's see. I guess I should have done this before I filmed the lesson. Oh well. Okay. So we've got 2 circles. So let's go ahead and just talk about what each type of circle is. So an inscribed circle, or inscribed angle, is an angle whose vertex is on the circle. So inscribed, inside, and on the circle. A central angle is when it's on the center of the circle. So central, on the center. Let's go ahead and talk about angle measurements. So depending on the type of angle, the measurement of the angle changes based on the arc. If an arc is 100 degrees, the inscribed angle is half. So my angle would be 50. However, if the angle is central, then the angle is equal to the arc. So inscribed is half, central is equal. Another thing that we need to make sure we remember, all arcs add up to 360 degrees. So all arcs add to equal 360. That's a very important piece of information. We need to make sure that we know that when I add each piece of my arcs together, all of them need to add up to 360. So let's go ahead and try the first problem. Number 1, I'm just going to compare based on what type of angle it is. So I'm going to trace out my angle, and that's the trick to circles. You need to be mindful of the angle measure and what angle you're focused on. So I'm going to trace my angle. My goal here is to calculate the length of this arc. And I'm going to now look at my vertex of the angle. So looking at the vertex, I notice that the vertex is on the circle, so I'm going to match it to this problem up here. So that lets me know that this angle is an inscribed angle. So if I'm trying to find the arc, I multiply by 2. So the angle is half, the arc is double. So all I'm going to do is 86 times 2 to get a measurement of 172 degrees. So that arc measure is 172. All right, let's try the next one. And I'm going to leave this little section up right here to kind of guide us here. So in this problem, we're trying to find the measure of angle FIH. FIH. Now I should notice that my vertex is on the center, which lets me know that this is a central angle. If it's central, then my arc and angle should be equal. So this is kind of what we're trying to find. What that means is I need to know what this piece is. Using our knowledge down here that all arcs add up to 360, I'm going to utilize the 160 and 140. So I know that this distance is 160, and I know that this distance is 140. So similar to triangles when we know they add up to 180, now I'm going to use the 140 and 160 to know that they have to add up to 360. So all I'm going to do here on my calculator, let's see, there you go. I'm going to do 160 plus 140, and that's 300. And then 360 minus 300 is 60. So that lets me know that this unknown arc is 60 degrees. And if I'm trying to find my angle that is central, I know that my angle also has to equal 60 degrees because that is a central angle. And central angles are equal to the arcs they intersect. All right, let's try another one. We want to find the measure of arc ZYX. So what I'm going to do is trace out that arc first. Z through Y, ending at X. Remember, when you're naming arcs, this middle letter is like a directional letter. So it means start at Z, go through Y, and end at X. The next thing I'm going to do now that I've identified my piece that I'm trying to find is I'm going to trace the only piece of info I have. I only have this 102. And if I trace the 102 degree angle out, I notice that its vertex is located on the circle, which means that this is now an inscribed angle. I also should see that the arc we've highlighted is the intercepted arc of the angle. So if I'm trying to calculate the arc, I'm going to multiply 102 by 2 and get 204 degrees. So circles, again, they're not a challenging topic, it's just a lot of formulas. Let's try another. Our goal in this problem is to calculate the measurement of this little half arc right here, this little question mark. When I look at this picture, I should be able to pick up a very important segment just by looking at my problem. I should notice this chord that goes through the center. This is called a diameter. Let's see. A diameter is half a circle, and it's 180 degrees. So that lets us know, okay, this whole distance for my half of circle has to be 180. That is very, very important because it's a diameter. That's going to be useful to us to get to the question mark because we know that we're dealing with only half of a circle. Okay? The next thing I'm going to do is trace out my number that I actually have. I've got 47 degrees. So that actually corresponds to this arc. To find the measure of that arc, I notice that this angle is inscribed. So to find the measure of the arc, I multiply by 2. So 47 times 2 is 94. I should know that this whole half circle has to add up to 180. So to find question mark, I do 180 minus 94 to give me a total of 86 degrees. So the question mark is 86 degrees. Okay, we've got 2 more examples. Let's try another one. This problem is very similar. It's kind of a combination to the second and fourth problem that we did. So looking at our problem, our goal is to find the value of this question mark. So I'm going to trace it out. I should utilize the values that I have, and the only values I have here are 112 and 98. Now this is very similar to the second problem we did. Remember, all of the arcs have to add up to 112. So 360. All arcs add to equal 360. I have the 112, and I also have this arc that's 98. That means to find this missing one, we're going to add 112. Let's see, I'm going to try to do this so you can see it in my calculator. There we go. 112 plus 98, and I get 210. So 360 minus 210 is 150. So that means I'm going to take the 150 and I'm going to put it here. Now I have all arcs that add to equal 360. Now my goal is to try to find this inscribed angle. And again, I know it's inscribed. The vertex is on the circle, so this is inscribed. Okay. So if I have the arc and I'm going into the circle, I divide by 2. So half of 150 is 75 degrees. This last example involves actual algebra that needs to be done to solve. So the first thing I'm going to go ahead and do is highlight my angle. And yes, we have a diameter here, but really that diameter is not that helpful. If I highlight my angle, I have everything I need. I have my arc and I have my measure of my angle. This angle is, again, inscribed. And I'm just adding that as a reminder, which means if I want the arc, I multiply by 2. Okay, so 2 times 32 is 64. I know that this has to equal 64 degrees. So what I'm going to do is I'm going to set these equal. 6x minus 8 equals 64. Add 8 to both sides to get 72. When I divide by 6, my x value is 12. That is one way to do this problem. I am going to show you how to do it another way, just to kind of help you. This is the first method, okay, knowing that it equals 64. Another way to do this is that the angle equals half of the arc. Okay, so my angle measure is 32, equals half of my arc, which is 6x minus 8. Now, instead of distributing the 1/2, I'm going to clear the fraction by multiplying by the denominator, which is 2. The 1/2 and 2 cancel, and I get 2 times 32, which is 64, equals 6x minus 8. And if I pause here, I should notice that these two values are identical to each other, and my answer is going to end up being 12. So it is up to you if you want to do the legwork by multiplying by 2 first, or if you want to clear the fraction. But you should know, at this point, once you clear the fraction, regardless of how you set it up, you get the same answer. This one just takes a little bit more effort. So honestly, it's up to you. I would probably stick with the 1/2, only because it helps you with the formula. But if you're not going to forget that, this way is faster. So things you need to remember about central angles and inscribed angles. Central angles are located on the center of a circle. Inscribed are located on a circle, and they're half the measure, whereas central are equal. And then also all of your arcs have to add to equal 360.